Recording in progress. Hi, students. In this lecture, I am going to discuss problems. Let us see first one. Let's see first one. Let us consider two blocks. Let us take mass 3 kg, 3 kg, 2 kg, and you are given here coefficient of friction 0.2 and here 0.3. Let us say applying a force F. Now question is, if F equal to 10 Newton, calculate frictional force at each contact, means by ground on 3 kg block, by ground on 2 kg block, next force by 3 kg on 2 kg block. Next F equal to 15. So for these two forces, we have to calculate frictional force, right? Let us see how to start. So first we have to focus, does system move or not? That is what we have to cross check. So for that, first focus limiting friction at each contact. Limiting friction for 3 kg block. This is 0.2. So limiting value 6 Newton. Now same thing for 2 kg block also, right? Normal reaction is 20, 0.3. Total is now 6. So at this contact limiting value 6. At this contact also limiting value 6. So if you want to move the system, we have to apply minimum 12 Newton. We have to apply minimum 12 Newton because when they are moving, friction will be opposite, right? So first one given 10 Newton. That means for 10 Newton, system does not move. Therefore, on each block, net force must be 0. I am repeating, on each block, net force must be 0. Okay. Let us draw FBD for 3 kg block and 2 kg block separately. For 3 kg block and 2 kg block separately. This is a 10 applied force. At this contact limiting value 6. Limiting value 6. So that is now towards left side 6 Newton limiting value. But you can see this is not able to balance 10. So now remaining is force by 2 kg block on 3 kg block. Let us take it as N. Okay. So we are knowing that for 10 kg, for 10 Newton, system does not move. Okay. That's why on each block net force must be 0. So here what we can say is N plus 6 equal to 10. N plus 6 equal to 10. That implies N equal to 4. Right? So force by 2 kg on 3 kg is 4 Newton. Now coming to 2 kg block. Coming to 2 kg block. 2 kg block applying force on 3 kg block, that is a 4 Newton. Then by 3 kg block on 2 kg block, it is same 4 Newton. But we are knowing that net force 0. So here limiting value 6. This is only 4. Friction is self-adjusting. Therefore, a friction is now 4 Newton, right? So on 3 kg block, it is a 6 Newton limiting value. By 2 kg block on 3 kg block, 4 Newton, same acting on 2 kg block. Since net force 0, friction must be equal to 4. So we have learned that static friction is a self-adjusting. So it is 4. Okay. So like this, we can solve the problem. Now coming to if F is 15, again see carefully, F is 15. If H is greater than 12, right? So system comes into motion. When system comes into motion, friction will be kinetic. Friction is kinetic. So here given 0.2, 0.3. So here nothing is mentioned. So we are taking nu s and nu k both are same. So since system is moving, frictional force on each one is kinetic. So which is equal to here mu k into normal reaction. That is equal to 6. For 2 kg also same mu k into n. So here mu k and mu s both are same because they are not given separately. Okay, both are moving as a whole. When they are moving, they can ask like what is acceleration. So if they ask acceleration, what we can do is applied force 15, frictional force 6 and 6, total 12. So net value is now 15 minus 12. This net force equal to mass into acceleration. Okay. Then see what is acceleration. 15 minus 12, 3. 3 by 5. 3 by 5 means 0.6 meter per second square. Okay. Next, if they ask force by 3 kg block on 2 kg block or by 2 kg block on 3 kg block, see what we can do. So I am taking here for 2 kg block free body diagram for 2 kg block. So on 2 kg block, one is force by 3 kg block. So take it as n dash in second case. Frictional force is 6 left side. Net force equal to mass into acceleration. Net force means n dash minus 6. This net force equal to mass is 2 kg. Acceleration is 0.6. Okay. So n dash equal to 2 into 0.6, 1.2, 6 plus 1.2, 7.2. This is a force acting on 2 kg by 3 kg or on 3 kg by 2 kg. Okay. So like this, we can expect problems. Okay, let us take one more problem. Right. Let us take now same blocks 2 kg and 3 kg. 3 kg and 2 kg and take here mu values 0.2 and 0.3. Applying a force F here 10 Newton and here also applying force. Now only changes one more extra force. One extra force is acting. Let us take this as 20. Okay. Now see how to solve it. Again, we want to calculate frictional force acting on each block at the same time by 3 kg block on 2 kg block. How much force acting? So again, same question. Only changes having one more force. So first we have to focus. What is net force? Here 20, this is a 10. Net value is 10, right? That is left side. But here limiting friction 6. Here also limiting value 6. So if net value is more than 12, because 6 plus 6 is 12, more than 12, system moves. So here first condition, system does not move. System does not move. Okay. That means on each block, net force must be equal to 0 on each block. Let us take a free body diagram separately for each block. For 3 kg block, see how many forces are acting. Applied force 10 Newton by 2 kg block on 3 kg block. Normal reaction. Ground. From ground, frictional force at. This is 10. When this is 10, friction tries to balance it. At this contact, frictional force, limiting value 6. So I'm taking 6 here. Since net value 0, this n value must be equal to 4, right? So that 4 plus 6 equal to 10. Next, coming to 2 kg block. 2 kg block, see what we can do. Normal reaction by 3 kg block, 4 Newton. That is N. Applying here 20. Okay. I can say this is a 20 left side. Here normal reaction 4 right side. Net value 16. So this is 16 must be balanced by frictional force. But here maximum value is 6 Newton. That means on 2 kg block, net value cannot become 0. But we are knowing that system does not move. But here what we got? Here net force cannot become 0. That means this is not correct. Okay. Now start from 2 kg block. Instead of taking 3 kg block, first focus on 2 kg block. Okay. See carefully. So we are focused now first 2 kg block. On 2 kg block, force 20 is acting left side. Friction tries to balance it. So friction will be, it is 6 Newton, but not able to balance. So it requires how much? 16 more. That will be normal reaction by 3 kg block on 2 kg block. It must be 16. It is 16 Newton. Sorry, 14. Okay, 14. Because 16 remaining required 14. Now come this side. Coming to 3 kg block. Coming to 3 kg block. By 2 kg on 3 kg, normal reaction is 14. Right? Next. Here friction limiting value 6. So this comes into picture. But remember, before deciding friction, first focus the forces acting here. Here we're having one more, that is a 10. Right? This is a 14, this is a 10. So net value how much? Net value is a 4, 4 left side. So friction is now self-adjusting. It is a 4. Okay, which is less than limiting value. Means this is correct. Is a pointer. So when we are making calculation, if the value comes out to be either equal to limiting value or less than that, it is correct. But here what happened? We require 16. That is not possible. That means we have to start with the block on which more force is acting. Then we can save time. Right? This is a 4. right side 6, right side this is a 14. Okay, let us try next problem. Next one, let us focus almost same kind of question. Same kind of question. So take two blocks 3 kg connected by a massless string with 2 kg block. Apply force F here. Let us take same values 0.2, 0.3. Okay. Now again, if F equal to 10, next F equal to 15. Find the frictional force, find tension. So in the earlier problem, we have taken normal reaction rate because the blocks were in contact. But now it is spring. So we have to find tension. So we have to find tension and we have to find frictional force on each block. Okay, right. See how we are starting. So first we have to focus what is limiting value. Again, limiting value 6 Newton because 30 into 0.2. Here also limiting value 20 into 0.3. 6 and 6. Right? So if you want to move the system, we have to apply minimum 12 Newton. So when we apply here 12 Newton, system is about to move. And if we apply force slightly more than 12, system comes into motion. Okay, right. So now on each block net force must be 0. So I am focusing to the free body diagram for each block separately, applying a force of 10. When this is a 10, friction tries to balance it. Friction can provide maximum 6. How much? Maximum 6. But not able to balance at 10. So now tension must be non-zero. So now tension T must be equal to 4 Newton. So that sum equal to 10. It is a balancing. Now come this side. 2 kg block. 2 kg block. Tension 4 Newton. Right? Tension 4 Newton. So here we are knowing that on 2 kg block also net force equal to 0. Right? So here friction is self-adjusting. Yes, it is now 4. Friction limiting value 6. So any value up to 6 is possible. Now it requires only 4. So friction provides only 4. Okay. That means here friction is limiting value. Here friction is less than limiting value. Right. Now coming to the next one. When you're taking F equal to 15. So again same as the previous one. Let us see. 15, which is greater than 12, right? So system comes into motion. System comes into motion means frictional force on each block. It is a kinetic on each block. That is equal to mu k into normal reaction. Okay. It is now 6 Newton on each block. That is fixed. Right. Now focus tension how much. Okay. So first what I'm doing is applying force of 15, frictional force 6 plus 6 is 12. So net force is 15 minus 12, which is equal to 3. So from this I can write acceleration is 3 by 3 by 5, which is equal to 0.6 meter per second square. Okay, right. Now I am focusing 2 kg block. Then see what happens. Focusing 2 kg block. Tension. How much tension? That we have to calculate. Since it is moving, friction is kinetic, which is equal to 6. So net force is now T minus 6. This net force equal to mass into acceleration. Acceleration is now 0.6. So tension equal to 6 plus 1.2, 7.2. We got same right in earlier question. Okay. So in fact, both are same kind of questions. Just we have taken here tension. In the earlier problem, blocks were in contact. Okay. Let us see next problem. Now in this also, we focus force applied on both blocks. Same as earlier question. It is a 3 kg block connecting by string. 2 kg block. Here 0.2 mu value. Here mu value 0.3. Applying a force, that is, take it as 10, and applying force here 20. Okay. So same as the previous question. See once. Limiting value 6 here. Here also limiting value 6. So to bring the system into motion, there must be a minimum force of 12 Newton. But you see, this is 20 and this is a 10. So net value is a 10. So system cannot move. Therefore, on each block, net force must be equal to 0. And in the previous question, we have seen that if you are starting with the 3 kg block, we got wrong answer. There I told that start with the block on which more force acting. Okay. So start with the 2 kg block. Then see what happens. On each block, net force must be 0. This is a 2 kg block. Applying 20. Friction tries to balance it. Limiting value 6. So it can provide only 6, but it requires 20. So 20 not possible. So it provides a 6. 6 Newton. We are knowing that on each block net force equal to 0 on each block. So remaining must be 14. So tension must be 14. Okay. Now come this side for 3 kg block. This is a tension 14, right? So tension 14. Applied force is 10. Now you can see again, net force on the block is 0. Net force. It is now 14 and this is a 10. So remaining how much? 4. 4 right side. And we are knowing that static friction is self-adjusting because both the blocks are at rest. So static is self-adjusting. It requires a 4. So frictional force becomes a 4. So that 10 plus 4, 14. This is now 14, right? So this is correct one. By mistake, if you are starting with a 3 kg block, we get wrong answer. See earlier what we got. Just recollect once. If anybody is starting directly with a 3 kg block, we get wrong answer. See, 3 kg. This is, sorry, this is a 10, right? Left side, 10. Suppose it is friction, is a 6, right side. Then we are saying tension equal to 4, right? Now coming to 2 kg block, see what happens here. 2 kg block, tension 4. This is now applied force 20, net value 16, 16 right side. So friction has to provide 16 left side, but friction maximum value 6. So friction cannot balance this. Therefore, on 2 kg block, net force cannot become 0. So this is wrong. That's why we have to start with the block on which more force is active. Okay. So it is mainly basing on free body diagram. If you are thorough with the free body diagram, you can solve all questions from friction. Okay.